Hello students and welcome to another year here at the HTL Leonding. My name is Rainer Stropek and I'm going to be your teacher in this Programming for Beginners course. In contrast to many other videos that I publish about my teaching and about my working, this course is not for experienced coders, but this course is exactly for you if you have no programming skills yet or your programming skills are rather limited. This is the first grade of the HTL and I'm proud and I'm looking forward to being your teacher in the next few months. Let's dive right into the topic, and before we deal with coding stuff, let's talk a little bit about the course organization and what you can expect and what you can't expect from this course. First, the slides that you see here on my screen can be found under this URL. So type in this URL in your browser and you will get directly to these online slides. I will also add this link to the description of the video, so you just have to click on the link and you are right in the middle of the course. If you are struggling with English a little bit, you can always use the browser's translation function. You can right-click on the site and here you see that you can say translate to, in this case it says Deutsch, which means German, so you can translate this site to a language that you are very well familiar with. However, coding has a lot to do with English, so try to stick to the English material as much as possible because mastering English, speaking English fluently will be an important skill in your journey to becoming a better coder. When I give this course in classroom, this would be exactly the time where we introduce ourselves to each other. Well, this is the video version of the course, so you can re-watch it at home, so I can't ask you to introduce yourself. But let me quickly introduce myself for those of you who weren't in the classroom or who do not participate in the course in person. My name is Rainer Stropek. I already mentioned that. I am from Austria. Here I live in Leonding and I have graduated from the very school that this course is from, the HTL Leonding, many years ago. In 1993 I graduated from the school and ever since I have been writing code. I'm a passionate coder and I always say every day where I can write code is a good day. And so I'm looking forward to this awesome course, to learning to make the first steps towards becoming a professional software developer together with you. Now, what do you have to learn to become a real good coder? Let me make my video here a little bit smaller and put it here, maybe up to the side, so we have enough space for the important material here. Now, the first thing that you're going to learn in this course is to speak the language of the computer fluently. What does that mean? The computer doesn't speak the language that we are used to as humans. We cannot tell the computer, so we cannot give the computer commands in spoken language, at least not on a technical low level. I know nowadays there are artificial intelligence applications which can turn spoken or written language into code, but this is already an application that somebody had to develop. You are going to learn how to develop such applications, and if you work on that low level, the computer simply doesn't understand English or German or whatever language you speak. So to become a coder, we have to be fluent in the language of the computer, meaning programming languages. That's the first thing, the first tool that you have to learn. Speaking of tools, the next thing that you have to learn in order to become a successful software developer is you have to master the tools which are necessary to interact with the computer. For instance, typing. Typing is one of the most important things that you have to practice over and over again. So you can give instructions to the computer quickly and effortlessly. Only if you can do that, if you master your tools, you are going to be a good and efficient software developer. And last but not least, you have to work on your general problem-solving capabilities. In specialized language, this is called computational thinking. And what computational thinking means is that you take the first two things, so being able to give the computer commands and knowing the tools for how to do so, applying these two things to real-world, meaningful problems. So you want to solve problems that really matter, and that is what you have to develop. In this course, I will teach you the very fundamentals of all three things. We are going to learn a programming language, we are going to learn tools, and we are going to practice our problem-solving capabilities. One thing at the beginning, I cannot make you a great coder. So if you watch this video online, if you sit inside my courses and you just watch me coding or you listen to what I say, you might understand the concepts, but this will not make you a great coder. The only thing that makes you a great coder is practice, practice, and practice. Mastery always comes from practice. So this is my important wish to you. Whatever you hear in this course, sit down and practice it. Do it yourself. Having said that, let me give you some things that you should avoid in order to reach this goal, becoming a great coder. First, avoid learning things by heart. Learning things by heart might be important for other courses, but not for coding, for software development, for becoming a programmer. It doesn't make sense to learn things by heart. You will learn things by heart, but that has to be a side effect of practicing. So just focus on practicing. Sit down and code. Just do it. And you will see things will start to come naturally to you. Avoid just focus on watching people to code. You shouldn't just watch me or watch people on YouTube coding. Passively watching does not mean practicing. You have to sit down and do it. The next thing that I would like you to avoid in this course is to try to make too large steps at once. No, in this course you will not learn how to build the greatest and most fancy 3D adventure game that you can imagine. Building something like that takes years and years of practice and experience. Try to get better by practicing small things. Please listen to me and the other teachers when we tell you that you should limit the tools that you use to a certain tool set. Although there might be other tools, even more powerful tools, which bring you faster to the goal that we try to reach, but in many cases we will tell you that you shouldn't use these tools at the beginning because it's important to practice certain things before you're going to use high-level tools which automatically generate a lot of code for you. And also, don't try to be overly smart. Maybe some of you have already learned some lessons in terms of coding, or you have seen YouTubers doing some fancy stuff with fancy language constructs or things like that. Avoid those things. Try to apply the knowledge that you really understand. That is another wish from me to you in this course. And last but not least, please do not copy just code from others. Sometimes you get homework, and of course you can fire up your favorite search engine, type in some search criteria, and probably many of the homeworks and things like that, you will find solutions for these homeworks online. You could just copy them, and then you might think you outsmarted me because you didn't have to do the work. But you outsmarted yourself, because at the end of the day, what did I say? You need the practice. It's perfectly okay to recreate solutions that you have seen on the internet, on YouTube, that you have seen me typing, for instance, in the course or in other courses, in other videos. That's perfectly fine. But always sit down and code it yourself. Code it yourself, make some mistakes, try to solve the mistakes, compare your solution with the solution of really good coders. That is perfectly fine. But don't simply stupidly copy code with Ctrl-C, Ctrl-V and you're done. That will not make you a great coder, and that will definitely not lead to a successful ending of this course. For those students who are in the classroom, I have created a course calendar. The link is in the slides. We will discuss this in the classroom. I don't think it is worthwhile repeating that on the video. And also the grading scheme, if you're interested in, you can follow this link and you will learn more about that. But that is something that we discuss in person. I will not repeat it here on video. And with that, I think we are ready to get started. Let's get going. Let's write code. In this course, we are going to program in C#. Yes, it's called C#, just like the musical note C#. I have a picture here in my slide. Maybe some of you play an instrument, a musical instrument, then you might be familiar with the musical note C#. You might ask yourself, why is this programming language called C#? And I will tell you that in a second. For now, let me start by telling you that C# is a programming language. Now, what is a programming language? A programming language is a language that we as humans can speak or write. It's relatively easy once we got accustomed to write our intent, to write commands about what we want the computer to do in this programming language. And on the other hand, this programming language can then be turned into a binary language, binary, ones and zeros, into a binary language that the computer can understand directly. So it's a kind of communication tool so that we can express our intent. Then we compile this program, this intent, into a language that the computer can understand, and then the computer can take this code, this binary code, and execute it. The CPU, the central processing unit in your computer, is then able to execute the commands that you intended it to do. I promised you that I tell you where this strange name C# comes from. You see, there is a classical programming language. In fact, I am old, you see. I learned programming with a very old programming language, and it's called C. C is a very famous programming language, and many software products on this globe, on this world, have been written in C. Probably large parts of the operating system, maybe Windows, maybe Linux, maybe macOS, have been written in C. So it's one of the widely used programming languages in the world. And now C# is a development from C. So we say it's part of the C family languages. It has some similarities to the C programming language. And because it's not C, it's a development of C, the inventors of C# thought, hey, it would be nice to keep this letter C and indicate somehow that this is something of a higher abstraction language, of higher abstraction level. You see, C, higher, C#, makes sense, right? If you play a musical instrument, you know what I mean. So remember, C# is a C family language, and this is why the name is as it is. By the way, there is also a language, funny thing, that is called C++, which is also a further development of the C language. So you see, it is kind of a thing for inventors of programming languages to take the letter C and put something after the C to indicate that this is something new, but still part of the C family. C# is really a very popular language. It's one of the top 10 most popular programming language in the world. So if you know C# and if you understand C#, there is a lot of work that you can do. Companies will want to hire you once you graduated from the school. So knowing C# is a great thing. There are many other programming languages, and we can follow this link here to see some other languages. Here you see the so-called Stack Overflow survey. If you're new to coding, you might ask yourself, hey Rainer, what is this? Let me show you that. What is this Stack Overflow here? You will use Stack Overflow a lot because it's a great database of solutions for certain coding problems. But for now, let me tell you that the Stack Overflow developers, they make a yearly survey and ask people which programming languages they use, which programming languages they love, and so on and so on. And here you see, we are talking here about the, let me put my video here, we are talking about the most popular technology languages. And you see here, JavaScript is a language, Python is a language, TypeScript is a language, Java is a language, and here you see C#, and here you see C++, and here you see C. See? Many of the languages that we talked about a minute ago can also be found here in the most popular programming languages on Earth. See? In our school, you learn, let me mark that for you. You are going to learn JavaScript, you're going to learn HTML, CSS, you're going to use SQL, you are going to learn TypeScript, you are going to learn Java, you're going to learn Bash, you're going to learn C#, you're going to learn C++, you're going to learn C, and even a little bit of Python. So you see, in our school, the next 5 years that you stay in this school, you will learn quite a bit of programming languages. And in this course, we start with C#. C# is just a programming language. But you know, having just a programming language is not enough for practical programming. We need an additional thing, a so-called platform. Now, what is a platform? Let's talk about this a little bit. A platform offers you tools to build and run software. What does that mean? C# is the language that can be turned into a binary code that the CPU can execute. I told you that already. But in some way, we have to be able to start this program. This program needs to store data, for instance, in memory or on the disk, if you want to persistently store data that remains there even if you shut down your computer and you turn it on tomorrow again. All these things like storing data on the disk, in memory, loading a program, exiting a program, all these things are done by the underlying platform. Okay? And our platform, the platform on which C# runs, is called .NET. Dot like the dot here, and net is just the name of the platform. The .NET platform is an open source software. That means that the software, it is mainly maintained and developed by a company called Microsoft, which you probably know maybe from Windows, maybe from Xbox, maybe from Minecraft, maybe from GitHub. This is a very, very large software company. They are primarily investing in C#, but they make all their developments free to use and freely available, and they also allow contributions from other developers. So once you became a very skilled developer, you can even add your own features to .NET or C# because it's open source. It's not just open source, it's also cross-platform. That means that you can use C# and .NET to write programs for Windows, for Linux, for macOS, for your iPad, for your Android phone, and many other platforms. .NET is not limited to C#. Different people like different programming languages. I just showed you a bunch of programming languages on the slide before. In this course we're using C#, but even if we would stick to .NET, we would have a lot of choices when it comes to programming languages. Two other famous languages which are widely used and also are based on .NET are F# and Visual Basic. You can Google these programming language names and maybe take a look at code, but they are not relevant for this course. Although they are very interesting languages. In particular, F# is a super interesting programming language. Visual Basic is a great language for a beginner, but it is not that relevant anymore. In the past, it was super relevant, but nowadays, not so many people use Visual Basic to build great new applications. Do you want to start? Do you want to get started? I tell you so much theory, so now we should jump right into the topic and talk about what we need on our computers to run our first C# application. So what do we need to get started? First, we need an editor. An editor allows us to type in text, the text of our programming language. There are many editors out there, and examples are mentioned here on this slide. Vim, Notepad++, Visual Studio Code, Visual Studio, and so on. In this video, in this first exercise, first hands-on to coding, we are going to use Notepad. But in quick succession afterwards, we are going to switch to Visual Studio Code, which is, at least in its core, also an open source software which runs on all different platforms that you can imagine. The second thing that we need besides an editor is a shell, or also called a command window or terminal window. There are multiple different names for this thing. Under Windows, you typically use either CMD or something which is not mentioned here, which is called PowerShell. There is also the Windows terminal in Windows, and in Linux, for instance, you would use, for instance, the Bash shell. These are just 4 or 5 available shells, but there are many more shells that you can use. And over the course of your career here at the HTL Leonding, you will come in contact with a large number of different shells, and you will learn how to use them, how to efficiently use them, and how to perform crazy stuff with them. They are really powerful. Now, the last thing that we need in order to do our first example is the C# compiler. The compiler, and this is important, remember that, the compiler is the software component which turns the programming language that you use to express your intent, to turn it into binary code that the CPU, the central processing unit, can execute. It turns human readable text, programming language, into machine readable and executable programs. And the C# compiler comes with the so-called .NET SDK, so we need to install the .NET SDK, which we will do in a second, or I did it up front, of course, but I will tell you how you can install the .NET SDK on your computer in a second, okay? Nice. Last but not least, once we turned our program into a binary program, we need something to be able to start this program. And for that, we need the so-called .NET Runtime. The .NET Runtime is also part of the .NET SDK. Its job is essentially to load the program from your computer's storage, your hard disk, your solid state disk, or whatever is built into your computer. There are other courses where you deal with how a computer works on the hardware level. I will not go into details, but I think many of you have already an idea what storage means. So its job is to load the binary program from storage and then do all the necessary things in order to really start it. Okay, so these are the 4 things that we need in order to get started. An editor where we can type in our code, a shell where we can interact with the .NET SDK, the compiler and the runtime, the compiler, third thing, which turns our programming language into a binary application, and fourth, the .NET Runtime, which really starts our code and offers a bunch of helper tools for our code in order to run successfully. Before we immediately jump right into it, I want to give you a tip which is not that relevant for this course, because in this course you need to install all the tools that I tell you. But these things are still important. Imagine that you are, I don't know, on your parents' computers, or you are on a public computer in a library or in one of our IT rooms, and you are not allowed, or you simply cannot install software. Can you still write C# code and execute it? Yes, you can. There are multiple so-called online development environments. Let me quickly show you that, and then we will close this slide and dive right into our real first example, I promise. But this might come in handy later on in the semester. Let me move that down here. For instance, something like this. What you see here, is a platform which is called .NET Fiddle. And you see on the left-hand side, it says C#. It says we write a console app, whatever that means. We are going to talk about that later in this course. And now I can type in some code. For instance, system.console.writeline, hello C#, something like this. You will learn about more about what this line means, but for now, just trust me, it makes sense. It is meaningful C# code, and I can simply type run, you see? Let's wait for a second, and here, down here, you see the output hello C#. I don't need to install anything. This runs on any browser on nearly every device that you can imagine. So if you want to practice C#, but you don't have an editor available or the compiler installed or things like that, use an online development environment. In fact, many of the examples that we will do in this course can also be done there. So this was just a quick sidestep to give you a really interesting insight. Word of warning, although some of these online development environments do not always offer the latest and greatest version of .NET. So always take a look at the version, whether this is exactly what you're looking for. If this is a very old version of C#, sometimes you can select it, then you have to remember that some features might not work. So don't be frustrated if not everything works. Most of the things typically work. Enough theory, I guess, right? Enough theory. I think we should get going, and I think we should write a little bit of code. So, what are we going to do? Please follow me, okay? Let's create an empty folder. That's the first thing that we are going to do. I will move it here so you can see it. I will move that on the left-hand side and move that one here, and here we are good. You see, I created an empty folder where I want to store my program. In this case, I used the temp folder, and the folder name is HTL, like the name of our school. Next, we have to start a shell, and there I have a tip for you, a small little trick which comes in very handy, and you already see it here in this animated GIF. You click up here and you type in CMD, and then you press enter, and that will give you a shell, you see? And this shell, let me zoom in here a little bit, this shell is immediately in the right folder. Woohoo! That's exactly what we wanted to do. And now in this shell, we can do some interesting things. One of the first commands that I'm going to teach you here, and you will use it a lot over the course of this year, is the dir command. Dir stands for directory. Give me a list of things which are currently stored in this folder. If I zoom in a little bit, you see that here that we have two very, very strange things here in our folder. It's the dot directory and the dot directory. Whatever that means, you will learn that later. It's not relevant for C#. The important thing is you have nothing else. You see 0 files, and that's the point. It's an empty folder. If we ignore dot and dot, which we will learn more about later on, the folder is empty. Okay? Nice. We have an empty folder. Not super useful, granted, but we can do the next step. Let's check whether we have .NET installed on our computer. And we can do that by typing in .NET, then a space, and then -- version. Press enter, and it should give you either something like 6.0 or 6.1 or 7.0 preview or something like this. It could happen that on your computer you get an error. when you type in .NET -- version and you press enter. In this case, you have to install the .NET SDK first. Let me tell you how this works. You can follow the link which is here in my slides, and then you come to this website. It's called download.net, and I can scroll down, and here you find a link which is called all .NET versions. You see that one? And this is exactly the link where you want to click on. And here you see the latest, greatest supported versions of .NET. There are a lot of strange abbreviations here on the screen, aren't there? It says .NET Core 3.1, and then it says LTS, and here it says .NET 6, and it says latest and LTS, but there is a .NET 7, so why is this latest? And here it says preview. Let me tell a little bit about what we see here. You see, the .NET platform comes with us in a specific version, and every year a new version comes out. And typically, the new version always comes out in November. So now, if I take a look on my date here on my computer, it's September. So we are still a few months away from the next version of .NET. And the next version of .NET will be 7.0. That will be the next big version of .NET. The currently available stable version of .NET, we call it stable because it is supported for really critical, performance critical and reliable application. The latest stable version is .NET 6. Now, which version do you think we are going to use? You think .NET 6? Ah, no. Hey, we are here in school. We are brave, right? We are going to use preview versions in this course. Of course, if we fail, we can always go back to the stable versions. But hey, we are living on the edge here. Something like this. Okay, so if you want to follow me and if you are brave and want to use the preview version, just click here on .NET 7, and that will give you a lot of options what you can install. And I think, as far as I know, most of you have Windows PCs, and therefore here this is relevant for you. Inside of Windows, it depends on your concrete computer which version you want to take. If you have a 64-bit CPU, you take that one. If you have a 32-bit CPU, you take that one. If you have an ARM CPU, you take that one. Most of you will go for this option here, the x64. If you are not sure, maybe you take the manual of your computer and look in there if it is a 64-bit or a 32-bit, something like this, and then you know what to install. And if you're still not sure, ask your teacher, ask me in the course, ask an adult who is familiar with computer technology, and I'm pretty sure they can tell you which version you should go for. But as I said, my guess would be, if you don't have anybody to ask, try the x64 version. It's very likely, if your computer is rather new, that it will work. Of course, you can also use for this course Linux. I'm perfectly fine with that. You can also use macOS. Perfectly fine with that. Just click on the corresponding link here to get installation instructions or download the necessary software. If you click on this link, it will take a second until the .NET SDK is downloaded. You see it here. It downloads currently on my computer. I don't need to install it again because I already have it on my computer. I just need to wait until it's here, and now I could click on it. You should click on it if you have to install it. If I click on it, I get a nice little installer. You have to press next, next, next a few times. It will install everything you need, and you are fine. Then you have your .NET installed on your computer. If you did that, very important note, close the terminal again. You have to close the terminal and reopen it. So again, click here, CMD, press enter, you get your terminal, you put it here, and you can try again .NET version, and you will now or should now see the version number. If it doesn't work, ask me, ask your teacher, ask a parent, ask your brother, sister, whoever is available. They can help you overcome any problems. Now that we have .NET, let's create our very first program. Okay, let's do that. We do that with a .NET command. Remember that. Whenever we work with .NET in the console, in the terminal, we always use the command .NET and some parameters afterwards. In this case, we say space new space console. Okay? Then press enter and watch what's going to happen. The system is working for a little bit. Maybe the output that you see looks a little bit different from my side here, because if you start .NET for the very first time, a lot of additional stuff is printed on the screen, but at the end of the day, the system should have created a new program for you. Do you want to see it? Hey, let's check the content of our folder, dear. See? Welcome to the world of coding. This CS stands for, here, let me type it in, C#. Okay, CS stands for C#. Program.cs is the program that we just created. There are two additional files here, which we one file and one folder, which we currently ignore. The only thing that we are interested in is this program.cs. Hey, great! You just have generated a little bit of code. Are you curious how it looks like? Let's check it, okay? Type program.cs. Wow, what did I do? Did you see what I did? I was super fast typing PR and suddenly everything appeared. Haha, I have another trick for you here. See? Important thing, if you start typing something, like type PR and then you press the, let me write it here, tab character. It's the tab character on your keyboard. It's approximately in the left upper side where you can jump a few spaces typically. This is called the tab character. If you press tab, it will complete the name of the file. This is called statement completion or command completion or argument completion. It's called the completion function. So I can type PR tab and boom, type program CS is here. That saves me a lot of typing. And these are the tips that you should practice over and over again. Don't try to learn them by heart. Do them. Use them. And you will see within a few days, a few hours of practice, they will come in very naturally and it will make you a faster coder. Remember what I told you? You have to master the tools. And that is exactly what I'm talking about. Not type everything letter by letter. Learn the shortcuts. Learn the keyboard. Learn how to use it. That's important. In my case, it saved me a lot of keystrokes and I didn't have to type in the whole word program.cs. Let's take a look at the code, and here you see this is essentially the program. The most important line is this one, console.writeline hello world. Remember that, console.writeline hello world with a bunch of special characters, which we will talk about in a second. Now this is the programming language, this is the language for us as humans. But now we have to turn this thing into binary code that the computer is able to execute. And this is done using the .NET build command. Build builds the binary program that the computer can understand from our programming language, our C# code. Run it, see? Works. We get a warning because we are so brave that we use the preview version of .NET. That's perfectly fine, but this is exactly what we want to see. A green statement which says build succeeded. 0 warnings, 0 errors. That's exactly what I want to see. Curious what our program does? Maybe you can already guess it. .NET run and hello world. This is exactly what our app does. It prints hello world. So what have we done? Let's quickly recap, okay? I will zoom in here. No, I will do it like that. We have written some C# code, and then we used the compiler to turn this C# code into an executable. We call it an executable, into executable code. It's technically not perfectly correct. The code is not really executable, but for now, please excuse my technical being technical not 100% correct. It is code that the computer can execute with a little help. Okay, but we will learn about that later on. And this executable, then we took .NET Run in order to execute it on the CPU, on the central processing unit. C#, the compiler turned it into an executable, and .NET Run took this executable and presented it to the CPU, and the CPU executed it, and the CPU finally printed something on the screen. This is what happened here. Okay, great. Do you want to change something? Definitely. Now you can be creative. What I want you to do is I want you to open an editor. If you are on Windows, the easiest option is to run Notepad. Let me show you how this works, how you can open our program in Notepad. Just go to your CMD window and type Notepad, and then again, P-R-O, can you remember? What key do we use now? That tab key in order to complete the word program.cs. I didn't need to type it in. And if I press enter, Notepad will open up. It opened up on my second monitor. I'm sorry for that. Here it is. And here you see our editable version of the code. And now I ask you to change here the message. Please note that the message that is printed on the screen is enclosed here in double quotes. These are important. Don't delete them. The double quotes are super important. I will tell you more about that in the upcoming weeks. For now, you can change everything between these double quotes. So in this case, I say, I don't know, I love coding, something like this. So go on and change the greeting here. And if you're done, you can press File, Save, and close program.cs. In order to run the changed application, we need to build the application and then run it. But let me tell you a secret. If you just type in .NET Run and you changed the C# code, .NET will automatically compile the application before it runs it. So .NET Build is strictly speaking optional. You don't need to run it explicitly. You can take a shortcut and immediately write .NET Run. Do that, and finally, I love coding. This is exactly what I want to see, and you should see your message that you entered in your code. Great! Our exercise was successful. So, well done. We already turned coffee into code, or whatever you were drinking, maybe water into code like I. Or pizza into code when you just had your lunch or dinner, whatever. Well done. We just installed .NET. We wrote or generated our first application. We learned a lot about programming languages, platforms, remember .NET, about how to turn code, programming language code, into binaries, into executable programs which we can run, and many, many more things. For now, I want to close this video. I hope you enjoyed it, and be back for the next video where we are going to switch from Notepad to a more professional development environment, Visual Studio Code. And that Visual Studio Code will give us the opportunity, would make us ready for more advanced adventures with C# and .NET. For now, remember, mastery comes with practice. So, keep on coding. See you next time.